This video is about graphing an ellipse, and we're going to graph it. We're going to identify the center, the vertices, the foci. We're going to find the length of the major axis and the minor axis. If we needed to, we could figure out the domain and the range. But the deal with this one is it's not in standard form, and so we have to use the method of completing the square to get it in standard form. So this is the equation we've been given. We have to work on that to get it in better shape. So how you begin to do this process is you get the x terms together and the y terms together, and that is already going on. We have the x's beside each other and the y's beside each other, so that's excellent. And the next thing we're going to do is you factor out the coefficient that's in front of the x squared term from the x terms. So that looks like this. 4. If I factor that out, I'm left with x squared plus 72 divided by 4, and that is going to be 18x. And I'm going to be completing the square process, so I'm going to leave room to add my special thing that I add to both sides to complete the square. For the y's, I factor out the coefficient in front of the y squared term, which is a 25, leaving me with y squared plus 300 divided by 25 is 12y plus something. And then the next step is to move anything that doesn't have an x or a y in it to the right-hand side of the equation. So I subtract 1,124. But if I add something to the left over here, I got to add it to the right over here. If I add something to the left here, I got to add it over here. So let's figure out what it is we need to add to create a perfect square binomial. So right here, what you add to both sides is b over 2 quantity squared. This is just how you complete the square. It's part of the process. So what's in the b position is whatever is next to just the x. So b in this case is 18. So I would say, well, what is 18 divided by 2? That's a 9. So what I'm going to add to both sides is a 9 squared. But 9 squared is really 81. That's what that is. So what I added to the left was 81, but this 81's inside the parentheses. So you have to take 4 times 81. That's what you really added to this side. So 4 times 81 is equal to 324. So that's what I really added to the left, so that's what I have to add to the right. Okay, let's complete the square for the y's. B, in this case, is whatever's next to the y, and that's a 12. What I want to add is b over 2 quantity squared. So in this case, it's 12 divided by 2, which is a 6 quantity squared. I'm going to add 6 squared to both sides. So 6 squared is 36. So I really added 36, but it's inside these parentheses, so it's really 36 times 25, which is really 900 is really what I added to the left, so that's what I got to add to the right. Now we're ready to rewrite this or factor this x squared plus 18x plus 81. And when we factor this, it will factor into a perfect square trinomial because we put the special term in there that made this happen. So if you want to check this, you can multiply x plus 9 times x plus 9. And you'd find that this is equal to x squared plus 18x plus 81. So this factors into this. For the y's, we have 25, and we have y squared plus 12y plus 6 squared. This will factor into y plus 6 times y plus 6, or y plus 6 quantity squared. That is because we created a perfect square trinomial through this process. On the right-hand side, we just add these numbers up together. Negative 1,124 plus 324 plus 900 equals to 100. So what we're doing is we're trying to get this ellipse in standard form. So now I'm going to divide both sides by 100 because standard form has a 1 on the right-hand side. I can simplify this fraction. This ends up being x plus 9 squared over 25 plus y plus 6 squared over 4 is equal to 1. This is the equation of ellipse in standard form. The center is at -9, -6. A is equal to 5 because this is a squared. B is equal to 2 because that's b squared. So we can graph our ellipse. Let's go over here to -9, -6, and I'm just kind of ballparking this right here. So I'm just going to label this is my center. I'm going to go right 5 units here, left 5 units here. That's the longer axis. Oh, that doesn't look symmetric. Let me do a better job. We'll pretend like that's the right one. These are going to be my vertices because this is the longer axis right here. This is the longer axis, A. And then B, we're going to go up 2 and down 2. And so I'm just kind of sketching this in. That is not very pretty, but that's okay. This is my terrible looking ellipse, but there it is. This is my center. This is the vertex. This is another vertex. And then these are the off endpoints. So if I needed to label these, let's see that. The center's at -9, -6. There that is. V1 is going to be located a unit to the left of the center. So if this is -9, if I go -5 to the left, that will land me at -14. And I'm still at the y value, -6. V2 is going to be, I go from the center, I'm at -9, -6, and I go right 5 units. So -9 plus 5 would land me at -4, -6. Those are the coordinates for V2. The foci will be on the major axis right here. So they are C units, not this C, that's the center. They are C units from the center. Well, there is a relationship for ellipses that says C squared is equal to the absolute value of A squared minus B squared. Or if you just think of it in terms of bigger A squared minus bigger minus smaller, we find that C squared is 21. C is the square root of 21, which is somewhere between 4 and 5. 4 point something is what that is. So that means from the center, I'm going to go 4 point something to the right. And if this is 5 to the right, the focus is going to be, maybe that's where the focus would be. Let's call that. And the focus is going to be here. I'm a little inaccurate on my graphing, but I'll be very accurate when I label my points. The first focus, F1, is going to be C units to the left of the center. The center is at -9, -6. So the x-coordinate will be -9 minus C, the square root of 21, and it's still at -6. The F2 is going to be C units to the right of the center. So if the center is at -9, -6, I'm going to go -9 plus C, -9 plus the square root of 21, -6. So let's see. There's a center right here. The vertices, the foci, oh, the length of the major axis. Okay, the major axis is the longer one, so this time it's located horizontally. So this distance, this black is getting too much. From here to here, this is A, and from here to here, this is A. So the length of the major axis is equal to 2 times A. Well, A is equal to 5, so 2 times A is 10 units long. The minor axis is the shorter one. So in this case, it's the vertical one. So right here, from here to here, from the center to this part is B, and from here to here is B. So the length of the minor axis is equal to 2 times B in this case, or 2 times 2 because B is 2. So 4 units is how long the minor axis is. Okay, that's that one.